Data models are important for the following reasons.
The SAP BW star schema is made up of a fact table and dimension tables. There can be a maximum of 16 dimension tables in one star schema. The star schema is also called an InfoCube. The info objects in the dimension tables are called characteristics. The info objects in the fact table are key figures. All characteristics have an SID or surrogate ID table. The characteristic SID table is created when the characteristic is activated. The SID table contains an SID ID for each characteristic value. The SID ID represents the characteristic value in numeric INT4 format and is generated by the system when values are loaded. Reading numeric values is faster than reading alphanumeric values. As each characteristic in a dimension table is represented by a numeric SID ID, the read performance on the InfoCube is greatly enhanced. If a characteristic, such as customer or product, also has master data tables, then the SID table is also the link between the master data and the characteristic in the dimension tables.
The BW extended star schema is subdivided into a solution-dependent part, that is, InfoCube, and a solution-independent part, attribute tables, text tables, and hierarchy table. The attribute, text, and hierarchy tables can also be shared among the other InfoCubes. The attributes of the characteristics are located in the master data tables. One of the challenges in designing a solution is deciding whether to store data as a characteristic in a dimension table and therefore in the InfoCube, or as an attribute in a master data table. Data is loaded separately into the master data tables, such as attribute tables, text tables, and hierarchy tables. A display attribute is an attribute of an info object that can be displayed together with the info object. It cannot be used on its own. A navigation attribute is an attribute of an info object that can be displayed independently of the info object and also used to navigate. For example, it can be used to filter data. It has to be enabled as a navigation attribute in the info object that it is based on and switched on for each InfoCube. The naming convention for a navigational attribute is info_object_attribute, for example, 0customer_0country.
Use transaction list schema to display the tables in the star schema. For good performance, the number of rows in the dimension tables should be small compared to the number of rows in the fact table.
A simple way to retrieve the necessary information about the InfoCube tables is to use the program SAP_InfoCube_design.
After loading InfoCube data, it is possible to view the contents immediately in Data Warehousing Workbench using transaction RSA1. In the context menu of the InfoCube, choose Manage. Then, in the InfoProviders management screen, select Contents, InfoCube Content. From here, you can verify recently loaded data, select characteristics, navigational attributes, and key figures. Choose various settings, display SQL queries, and display execution plans. All characteristics, navigation attributes, and key figures are available for selection. The characteristics and key figures that are selected are displayed in the output list. Aggregation is carried out using the characteristics that are not selected. The maximum number of hits determines the amount of data that is returned. When you select the option DB aggregation, several records are taken from the database and brought together in one row of the list. The option output number of hits generates an additional key figure in the output list that shows from how many records were rolled up. The SQL statement is generated according to the field selection and restrictions and is sent to the database. For each statement, the database optimizer decides how to retrieve the data. The execution plan shows the path that was taken by the database optimizer. You can analyze the join statements and the tables that were read here.
By choosing tables or view information, you can display the indexes of the InfoCube. From here, you can view and update the database statistics if needed. In the Data Warehousing workbench, from the InfoCube context menu, choose Delete Data to delete the data from the InfoCube. After the deletion has completed, a report is displayed that shows all of the activity of the deletion process. All deleted objects are listed on this report.
If it is necessary to change an InfoCube and no data has been loaded to this InfoCube, the change can be done in InfoCube maintenance. However, if changes are necessary for an InfoCube that has already been loaded, the task may not be possible in InfoCube maintenance. In this case, use InfoCube remodeling. With InfoCube remodeling, it is possible to change the structure of the InfoCube without losing data. For example, it may be necessary to replace an info object in an InfoCube with another similar info object. Remodeling manages add, change, or delete functions for any characteristic or key figure in the InfoCube. Caution: as a precaution, it is recommended that a backup be made of the InfoCube before the remodeling process begins. There are three types of data store objects: standard, direct update, and write optimized. The qualities of each are summarized in the table Data Store Object Types.
The figure provides an overview of the standard data store object architecture. The standard data store object consists of the following three tables. Activation queue. New data is stored in this table before activation. The structure is like a PSA table. The key is made up of the request, data package, and record number. After activation, a request is deleted from the activation queue. Table with active data. In this table, the currently active data is stored. The table has a semantic key defined by the data modeler, for example, order number or order item. Reporting is done on this table. Change log. During activation, changes in the active data are stored in the change log. You can find the entire history of activations for the data store object in this table because data is not automatically deleted. If data targets are supplied with data from the data store object, in a Delta process, the data is read from the change log. The change log is a PSA table. That is why the change log also has a technical key that consists of the request, data package, and record number.
Data Store Object Contents check to see if there are any errors in the data you loaded into a Data Store object. You can also use it to selectively delete requests from the Data Store object. Deleting individual requests serves primarily to remove incorrect requests from the Data Store object.
This section describes about deletion of data store object data as per request.
This section explains about deleting data selectively.
Deleting data from the change log of a data store object is recommended if several requests that are no longer needed for the Delta update and are no longer used for an initialization from the change log have already been loaded into the data store object. If a Delta initialization for updates connected to InfoProviders is available, requests have to be posted before the corresponding data can be deleted from the change log. Suppose you have one info provider with the actual data for a logically related business area and one equivalent info provider with the planned data. To compare the actual data with the planned data in one query, you can combine the two info providers into one multi-provider. This is a homogeneous data model. Homogeneous multi-providers consist of info providers that are technically the same. For example, InfoCubes with exactly the same characteristics and similar key figures. In this case, the InfoCube with the planned data contains key figure planned costs and the InfoCube with the actual data contains key figure actual costs. Homogeneous multi-providers represent one way in which you can achieve partitioning within modeling.
Multi-providers impart a number of reporting benefits, including the following.
Following are the data load benefits of multi-providers.
The hybrid provider is a new object as of SAP BW 7.3. It provides a solution for situations in which large volumes of historical data are needed alongside operational, that is real-time data. It achieves this by combining two InfoProviders, an InfoCube for historical data and either a virtual provider for near real-time data or a standard DataStore object based on real-time data acquisition. To the end user, a hybrid provider acts as one consistent object for querying and transformation.
Ease of access to a combination of near real-time and real-time data in an efficient way means an end to the old paradigm of day-old data in the warehouse. The complex cockpits that were necessary to present old and recent data at the same time are redundant, as are the complex multi-provider scenarios that required much maintenance.
Semantic partitioning means that transactional data is loaded into different InfoProviders that are partitioned according to the following characteristics.
Semantically partitioned objects, or SPOs, allow users to create a semantic partition once and use it repeatedly. SPOs improve scalability and reduce development efforts when a new partition is created to extend the existing data model. An administrator of a BW 7.x system who wants to partition InfoProviders by geographical characteristics, for example, Europe, North America, and Asia, has to create a master InfoCube and copy it. The administrator must then manually create data transfer processes with different filter settings and info sources. Changes in the data model of the InfoCube or changes in the partitioning must also be applied to the InfoProviders manually. The figure summarizes the advantages that SPOs bring to data modeling. The following are the components of an SPO.
An SPO is always created with two info sources, one for incoming and one for outgoing data flows. The info sources function as inbound and outbound data layers for the object, which facilitates the integration of the SPO into a data flow. Between the info sources and the partitions, there are simple dummy transformations. Actual transformation of data takes place in the transformation objects underneath or above the inbound and outbound info sources. SPOs are integrated into data archiving and near-line storage concepts. Note that reporting is only possible on the partitions, not on the SPO itself. For reporting over multiple partitions, the partitions have to be part of a multi-provider. If the SPO consists of InfoCubes, the data is processed quickly due to the concept of partition pruning with or without the use of a BW accelerator. Partition pruning is automatically applied to InfoCubes. Only the partitions that contain the data requested in the query are read. If the SPO consists of DataStore objects, all partitions in the query are read, which can lead to performance problems. The following are the disadvantages of semantically partitioned objects.
You can access SPO administration in one of the following ways.
A transient provider is an info provider that allows analysis and reporting with BI tools, including BW OLAP functions on top of an application, such as a SAP Business Suite system. Transient providers are not modeled in BW's data warehousing workbench and the data is not replicated. Transient providers do not have persistence in SAP BW but allow reporting for the established Business Explorer or BEX tools as well as BI Consumer Services or BICS and MDX capable tools. BICS is the infrastructure software that drives access to the SAP BW data. The figure shows some of the advantages that these info providers bring. Transient providers provide the flexibility to access data in ERP in an efficient way. This efficiency is both technical and, in a way, functional. Users are able to use SAP BW queries to access the data residing in ERP. This provides a central reporting tool for accessing data in either SAP BW or ERP. In addition, it opens up access to SAP Business Objects reporting on ERP in an efficient way. The advantages are obvious. The same report could have been accessed with older versions of SAP BW, but it would have required a virtual cube and the transfer of the data to SAP BW during runtime with the added overhead of a transformation. All this extra overhead is eliminated with the new transient provider. The source data for a transient provider can be any of the following: a classic info set, that is, based on data dictionary tables or logical databases, not to be confused with the SAP BW info set. A data source, that is, via operational data provider framework in the Business Suite system. An analytical index built with the Analysis Process Designer or APD. Fast search index views, that is, only for SAP Business by design.
Analytical indexes were introduced in BWA 7.2. An analytical index is a BWA-only InfoProvider defined using the Analytical Process Designer tool or published from a logical BWA index. An analytical index can be used to generate a transient provider, that is, an InfoProvider that can be used by a BEX query without being modeled in the data warehousing workbench. Analytical indexes can be created and filled with transformed data quickly. They are therefore suited to quick improvised analyses.
A composite provider is an object that joins two or more existing analytical indexes. Both join and union operations are supported. For the join operation, both inner and outer joins are supported. The calculation is done on the fly at query runtime. The Lean Modeler tool is the design time environment for building composite providers. Note, the composite provider is the first BW object that uses a join operation in the BWA.
Modeling data flow eliminates the need to load the data into the SAP BW system. Instead, you can access it directly for reporting and analysis purposes. The virtual providers used as the data structure. A virtual provider is the type of InfoCube where the data is managed externally, not in SAP BW. Only the structure of the virtual providers defined in SAP BW. An interface with another system reads the data for reporting. Note, the system does not run existing exits or customer and application extensions such as Customer Exit, BTE, BADI for direct access to the source system. The following are the three types of virtual providers. The real-time InfoCube is an SAP BW InfoProvider. It is also used in applications like business planning and simulation and IP or planning InfoCube during planning functions.
The figure shows a typical scenario using a real-time InfoCube. This scenario incorporates business planning and simulation, IP or planning InfoCube, with a business consolidation system or BCS scenario. There are two types of data entry for this application. First, a user enters data manually. Second, automatic planning functions run. These planning functions might copy or re-evaluate data from the existing records. In both upload cases, the IP or planning InfoCube application calls a real-time interface to write the data directly into the InfoCube without any data staging technologies. The real-time interface is a function module that was developed for real-time applications but can also be used for other applications.
An F-fact table consists of different requests. The figure shows an example of one. In the example, the InfoCube consists of 3 requests. The first 2 are closed, but the third is open. All users write into the same, that is, open request, and can do so multiple times. The open request in the data warehousing workbench is displayed with the yellow status information. The short text for all the info packages that were open requests in the past or are now indicates that the request was created by the real-time interface. The closed requests have status information, but they do not have any monitor entries. For testing purposes, you can use transaction RS input. This transaction is not for productive use, but for creating test data in your test landscape.
There are 2 ways to load data to a real-time InfoCube. The first is to load the data via the SAP BW interface with standard data staging. The second is to load the data using the real-time interface. To load data to a real-time InfoCube using the real-time interface, different function modules must be called. If these function modules are used, no info packages are used. The function modules provide direct access to the real-time InfoCube. For debugging options, see SAP Note 302937.
There are several points to remember when switching the data load technology. The switch from real-time interface to SAP BW interface closes the open request and all unsaved data is lost, for example, manual data entry in IP or planning InfoCube BCS. The user does not recognize the switch until they try to save their data. To avoid losing data, only perform this maintenance function when no users are actively planning. When a request is being loaded into a real-time InfoCube, it is flagged as open, that is, with a yellow QM status until it receives 50,000 records from user planning. This threshold value cannot be changed. Once a request crosses 50,000 records, it is considered closed. If this data needs to be reported on before 50,000 records are added, close the request manually, that is, mark it green, to make the records available for reporting. To close the requests in a cube, you can use the program RSAPO_close_trans_request_all3. When executed, this program closes all open requests in all the transactional cubes in the system. If you want to close the request of just one relevant cube, leaving the open requests in other cubes untouched, create a program using the code in RSAPO_close_trans_request_all3 or use the function module RSAPO_close_trans_request. This program and a variant saved with the InfoCube details can be used in the ABA process type. You can also use the standard process type Switch Real-Time InfoCube to load mode to close open requests. This option closes the request and switches the real-time InfoCube to load mode simultaneously. If another user is trying to write some data to the same cube at the same time, an error message appears.
Note the following. An aggregate does not contain data from an opened request. The OLAP processor fetches data partly out of aggregate and partly out of the opened request. After closing an open request, the data will be rolled up automatically. DataStore objects for direct update ensure that data is available quickly. The data from this kind of object is accessed transactionally. The data is written to the DataStore object, possibly by several users at the same time, and reread as soon as possible. This is an additional function that can be used in special application contexts. It is not a replacement for the standard DataStore object. The DataStore object for direct update differs from the standard DataStore object in how the data is processed. In a standard DataStore object, data is stored in different versions, such as active, delta, modified, but a DataStore object for direct update contains the data in a single version. Therefore, data is stored in the same form in which it was written to the DataStore object for direct update by the application. In the SAP BW system, you can use a DataStore object for direct update as a data target for an analysis process. A DataStore object for direct update consists of the active data table only. Although the system creates the delta Q table and activation Q table, it does not use them. It retrieves its data from external systems using fill or delete APIs. The load process is not supported by the SAP BW system. The advantage to the structure is that the data is made available for reporting immediately after being loaded.
The table summarizes the function modules that can be used to write data to a DataStore object for direct update